I just want to say at the beginning, I do have a bit of a cold, so if I get sort of hard to hear, feel free to tell me. Um, I have the chat open right next to me, so I'll be answering questions as we go along too. Um, so first of all, my name is John Roper. I'm a developer working out of Boston. I'm one of the two main developers on the Crowdmaster add-on, and I've also done work on other add-ons such as the Cycles Material Vault and a lot of other different workflow stuff. So here, I'm going to start off by sort of displaying this little demo reel for Crowdmaster. This was the latest release. So that was Crowdmaster, and that's just sort of an overview of some of the more general features. Right now, we're working on a new release, version 1.3. So that's sort of what I'm going to be talking about today. So one of the biggest things, first of all, I should sort of explain what Crowdmaster is if you don't know. It's a crowd simulation add-on to do all sorts of procedural animation, mainly focused towards large groups of objects or people. And we can use it to do so many different kinds of things. There's going to be a link to the Crowdmaster website. And on that page, there are a lot of different examples and descriptions there that you can take a look at. With the new release, one of the biggest things is this what we like to call action sync, which is the ability for other agents, different objects in the scene, to see what the other agents are doing, so we can create scenes such as this. So each of these agents is checking every other one and trying to see which ones are available to fight and fighting them. So Crowdmaster can be used to create all different sorts of simulations. So I'm just going to demonstrate a couple here, starting off with this fight scene. And I'm just sort of going to walk through how this is set up, and then I'm going to sort of help set up a demo, another smaller demo scene. So this is the teams, the army demo here, and you can see our characters are pretty much just armatures with little objects on them. And we have this set up so that we have a simulation node tree and a placement node tree. And the first one of these, the placement, helps us actually add our people to the scene. And that's this one right here. So if I generate, you can see we have our two groups. And then the second node tree actually helps us simulate the agents. And I know these look a little complex right now, but I'm sort of going to walk through them, and you can see it's not actually as complicated as it looks. So just sort of going to run this for a bit just to show it is working slowly, but it's working. So firstly, we have our generation node tree, and it starts off with this agent group right here. And that is, right, we have these two characters. The first one is this action, and then we also have this character right here. And he's just sort of an armature with a little blocky head and all kinds of stuff like that. So we're starting off with that guy. And then we also have this object sword, which is just sort of a cylinder thing. And we can do what we call geoparenting, which is parenting this object, the sword, to the agent's bone called right hand. And that one is right over here. Right out here. Little sword. Next, we have the different objects that make up the character. So we have a shield, two different types of shields. We have a round shield and a sort of square shield. And what we're doing here is with the geo switch, we're randomly choosing for each agent which shield should be added by the parent to the character. And then that's set off to this character called Rebel, which is then placed in the scene with some positioning nodes, which I'll get into later. And then the same for the other characters. And then those get transferred down to lay out their positions. And then they're generated by hitting the generation button at the end. Just sort of trying to show how this all works and how you can set up one. I have a new test file right here in which I'm going to open some characters and sort of walk you through how to append them. This lady right here. And I'm just sort of going to walk through just a standard setup. The first thing we want to check for is that the agent, this character, has the rotation and scale applied, which they don't. So we're going to want to apply the scale. First apply the rotation, and apply the scale. And sometimes that sort of offsets the people a bit. I don't exactly understand why it does that. So what you can do is drag the person or the armature up and then set origin to 3D cursor so it's on the ground. The character here, right in the center, origin to 3D cursor. And then we can open the node editor and we can start placing this lady in our scene. So let's open up our group, which is this lady. And then we have this template node, which is our agent. And we can drag the node, connect the nodes up. Brain type, we can call this lady. This is pretty much the name of the agent. Positioning, we have many different positioning options. I'm just going to use random for right now, but we also have formation, target, which is placed on individual objects like stadium seats, things like that. And we can connect these up. And then here's where a lot of the action goes on with actually placing these agents. So right now, I'm going to want to set the actual number of agents to, I'll say 50. And then this location type, we have multiple different options. The first one, radius, is pretty much agents are placed in a specified area, which is a radius around the center of the scene. The second option, area, is a area in the scene from this point. So it's one of these sectors on the grid, meaning that we have a max X and a max Y. So currently they're set to 50. And what this will do is agents will be placed from this direction out towards the X direction up to a max area. And then those agents will also be placed backwards on the Y direction to a max area. So really in this area right here, this sector. And then the last option is a sector, which is, I know I was calling the other thing a sector. This is pretty much the area inside a specific circle, which can be placed anywhere around the scene. And they can be facing in a specific direction, things like that. But I'm just going to use radius for right now. And then this relax just helps you make sure that objects aren't penetrating each other. We don't need that. 50, I'm going to set this to 25. And then finally, we have this generate node, and we can connect that up. Generate agents. Takes a little bit because these agents aren't necessarily optimized. So Blender has to copy over that object 50 times. And now you can see we have all these people ranged in a circle. But they're just placed. They're not actually animated. So how can we animate these people? Well, we want another type of node tree. We see this brain type, we said is lady, the action, the agent name. So what we could do is we can go to the other Crowdmaster node tree, create a new node tree, name this lady, because that's the name in this one right here. And we also have a toolbar right over here with a bunch of options that I will get to later. So the first thing is we actually need to give a value that we want these agents to move at. So I'm going to say input and then an input node. And the type, there are many different types here. And right now I'm just going to use constant. This is just a general value that you can output. So I'm going to say 0.4. When simulating, these numbers can be pretty big, so that's why I'm using decimals. And then an output node. There are many output values. So the first RZ stands for rotation on the z-axis. RX is for rotation on the x-axis. RY is for rotation on the y-axis. PX is for position on the x-axis. PY is position on the y, and PZ position on the z. So what we can do is connect this output to the output node. And what's going to happen is this value here, 0.4, is going to be fed into the rotation on the x if we keep it as it's set up right now, but we can make it affect the position on the negative y. Yeah, negative y. So position y, and then the agents are rotated strangely to the wrong way. So what I can do is do negative 0.4. And now if I hit start simulation, sort of let it keep running, When we go into our 3D view, you can see all these people are moving forward at a rate of 0.4. So we can stop the simulation. Sort of play that back. There are a lot of objects in this scene, so what we can do is turn on simplify. Let's try just showing the wireframes. Oh, that's a bit faster. And you can see they're all moving forward. But we want them to actually be walking. So what we can do is we can pull in a animation, an action. And I have a number of them here pre-made. So I'll just do a walk. And then what we can do in this node editor is right here we have an actions option. You can create a new action. I'll just call this test because I feel like it. And let's look for walk. And then we can add a state action node, choose the action, test, and then we can do state start, put that right in there. And now if we hit start simulation, let it run for a little bit, stop it. Now you can see people are walking as they move. And their movement is a little fast. That's not the right one. We want these people. As they are moving forward, you can see that they are actually making stepping movements. And it's only moving at 0.96 frames per second because I have so many objects in here right now. If it were faster, you would see the combination better. And I actually have a couple of examples here that have been rendered out ahead of time just to sort of show these features here. So the first one, I already showed the armies. And we have this guy. And this isn't with the women characters. They're just sort of little cones. But this shows if I had sort of set that up and rendered the placement of those people on the ground. So you can see we can set them to just move forward along the ground. And follow a path like that. And then the other example was for armies, the setup that we can use for formations. So just sort of going through this. And these are all updates and features and timing fixes, all kinds of things that we are working on for the next release of Crowdmaster. And we're going to share that link right down in the bottom in the chat so that you can all get the new release when it comes out and test it. Here we go.
I got a question or two for you, actually, if you have a few minutes.
Yes, I do.
Okay, cool. So one of the bigger ones was comparing this, and of course this is going to happen, comparing this to, say, Massive, MiArmy, Golem. And I know you worked with Walter Schultz, one of the premier Massive artists, on this tool. Do you want to talk a little bit about it, kind of like where yours is at and how they compare, and just your thoughts on it?
Right, okay. So in comparing the systems, Crowdmaster is a mix of many different types of systems. the user layout, the way the system is actually functioned with the node trees and all the different nodes that we have. On the user side, it works actually pretty similar to Massive. There are a lot of things in common. In a lot of ways, at the same time, it is like Golem, and it's mainly sort of a more particle-based approach. Not that I'm saying that it's based on Blender's particle system, but the agents aren't as smart as they are in Massive, which we are working on currently. And then My Army it's not as similar to My Army as it is to the other systems. We have done a lot of research into all three systems to try to get it as close as possible and as usable so that it's familiar to people who have already done crowd simulation. Just sort of to summarize, Crowdmaster is set up UI-wise, user setup-wise, the way you set up the node trees, like Massive, and then it performs more like Golem, but we're hoping to get it to more Massive standards, and then it's not too clear. It's not as similar to My Army. And we've done a lot of research with all three systems to try to get it as usable as possible. Can you hear that?
Yeah, man. No, that was great. And I guess your goal ultimately is just to keep it, embedded inside of Blender and a part of that. One other question for me, at least, what do you feel you need help with? Maybe this is like a community thing where someone listening to this either now or in a little bit in the future might be able to toss you some help. What do you need help with?
Right. So we have a GitHub page. So this is all open source, and we some of our current projects can be found here. We have a number of different things. The biggest thing, sort of trying to increase the performance and accuracy of the system. And then also different things, visual feedback, pulling a lot of inspiration from Massive about different displays, different progress, really just support for making it a better, more industry standard system overall.
Cool, man. Well, with that, I think we're at the top of your bit. Why don't you give us some closing words before you head out?
Okay, yeah. So you can find the Crowdmaster website. It's jamroper.com/Crowdmaster. And on that site, there's the documentation, examples, obviously download links, where you can get the latest version and then the latest development version, which is that new release that we're working on. And then also the link to GitHub. So I would say go there, learn about Crowdmaster. It's always great to see users who are doing some crazy stuff with it. So we hope it's helpful for people.
Rock on, dude. Thank you very much. And
Thank you.
This looks amazing. So it's really cool to see like real proper crowd sims coming into Blender. And for those of you who are following us on the chat, I've posted that down there, jamroper.com/Crowdmaster. Check it out. Give them some feedback. Thank you, John.
Thank you.